Question 9, we can see differentiation here coupled with coordinate geometry. So a curve has this equation, and they are saying part A, find the equation of the normal to the curve at the point A, which is 4, 3, giving your answer in the form y is equal to mx plus c. In order for us to find the equation of any straight line, then we need to get what we call the gradient, and also at least one point through which a line passes. So suppose I have, maybe my curve is like this, and then there is this line here which meets the curve at only one point, which we call the tangent, right? And then this line which is perpendicular to the tangent at this point of intersection is what we call the normal, okay? And at the point of intersection, the gradient of the curve is equal to the gradient of the tangent. The gradient of the curve is always changing, okay? It is different on all the points on the curve, okay? But then the gradient between any 2 points on the straight line is equal. Now at the point of intersection, then these two are having the same gradient, okay? And to get the gradient of the curve, then we need to differentiate. So what is dy dx? Dy dx, put this one down here. You will have 2, then times that a half, then x. A half minus 1, that will be negative a half. Of course, when you differentiate negative 1, it will give you a 0. So that means we shall get x to the power of negative what? A half. Now, at this point A, x is what? X is 4. So we can put here, what do we get here as our dy dx? So it is going to be 1 over, because x power negative a half is the same as 1 over x power half, or the square root. So this one will give us a half, okay? So this one here is the gradient of the tangent. It is the gradient of the curve at this point, but also the same as the gradient of the tangent, okay? So this is the gradient of the tangent. And since these two are perpendicular, the tangent and the normal, then we know that m1 times m2 is equal to negative 1. So therefore, gradient of the normal is equal to negative 1, then divide by the gradient of the tangent. So this one will be equal to negative what? 2. And then using the general equation of a straight line, which states that y minus y1, which is equal to m into x minus x1. Remember, I said you must get at least one point through which a line passes, which is this one, and also the gradient which we have gotten. So y1 is this 3 here. So we shall have y minus 3, which is equal to m is this one here, negative 2. And then x, then minus x1 is this 4 here, okay? Then when we open the brackets and then we take this negative 3 to this other side, we shall have negative 2x here, then plus 8, then plus the 3. So meaning the equation of the normal is y, which is equal to negative 2x, then plus 11. As simple as that. Then they are saying here that a point is moving along the curve, this one here, in such a way that at A, the rate of increase of the x-coordinate is 3 centimeters per second. Part B, find the rate of increase of the y-coordinate at A. Now, they want us to find dy dt. So dy dt is actually equal to dy dx, then times dx dt. So that this one can cancel with this, but y and x are connected, okay? So our dx dt is actually given here as 3, the rate of increase. Suppose they said rate of decrease, then that means this value here would be a negative, okay? Increase is positive, decrease is negative. Now, what is the value? We need to find the value of dy dx for this one here, okay, at point A. But at point A, we found dy dx here, which is a half, remember? Which is a half, okay? So that means I will put this a half here, then times this 3 here, meaning our answer is going to be 1.5 or 3 over 2. As simple as that. And then they are saying that at A, the moving point suddenly changes direction and speed and moves down the normal in such a way that the rate of decrease Now you see that they are talking about the decrease of the y-coordinate is constant at 5 centimeters per second. Now we are using the normal. So what we are given here is dy dt, which is a -5. They talked of rate of decrease. Okay. Now, the equation that we are going to use here is the one for the normal because the coordinate has changed direction and it is following that of the normal. And the equation of the normal, we got it as y is equal to -2x plus what? 11. You see that? So meaning we have to get a dy dx here, which is actually this -2. Not so? That is the gradient of the normal. So dy dx is equal to -2, and you know that gradient on any straight line is always constant. So they want us to find dx dt. And dx dt is the same as dx here, then put dt here. That means here, since x and y are connected, I will put dy, then I also put dy here, so that this one cancels. You see that? But then dx dt, I mean dx dy, is the same as 1 over dy dx. So that means we shall have 1 over the -2 we have here, then times dy dt, which is -5, meaning the answer is going to be +5 over 2, because a negative divided by a negative, you get a positive. As simple as that.